want to take you through some of the process necessary to create one of my pinwheel design segmented turnings. This one here is clearly already glued together. The making of one of these is not too difficult. It's not too different either than a conventional 8-segment layup. Each cut angle is 22.5 degrees for 8 equal sized segments. Therefore you get the 360 degrees. As you see, when I assembled this though, instead of putting it point to point, I offset each one. The amount of offset isn't really critical. You can offset it by quite a bit and still get a good size piece out of it. The key is to keep the offsets equal all the way around as you go. I glue these up in 2s, and then I glue them in halves, and then I glue the whole thing together. So there's not a whole lot of magic involved with that. The key thing you want to do before you glue up anything on like this though is of course do a dry fit, make sure all the angles are perfect, and then you're ready to go ahead with it like I did here. I've got a piece of thin wood in between each segment to just accent it a bit. So when you're starting with a piece like this, you can see that there's a bit of work to do yet before you put it onto the base, and if you decide to put a top ring on it, you'll have to do that too. But we'll do a lot of that on the lathe. The first thing I want to show you is that I'm going to turn a rough circle for the outside and take most of these peaks off. They don't do us any good, and they'll cause us problems when we go to turn this. The way I do it is I have a number of these miscellaneous round blanks laying around, and you find one that'll fit in there fairly well to hold the point for your compass, and then you just put it in there, hold it securely, and draw a circle around to give you something to reference. Now you see I drop off this one because some of these have a void on them, and it's just the nature of the piece of wood that I was using. So again, I'm just going through here, give myself a rough circle to follow to cut the starting diameter out with, and you can see that there. Now we're going to go to the bandsaw, and I'm just simply going to cut that off to give us a round blank to continue to work from. Well, let's cut this blank and make it round. Well, you can see now that we've cut the waste off and we have a pretty much round blank. Perfect accuracy isn't really necessary at this point, so what the next step will be is I'll take this to the belt sander. This will be my bottom, and I'll sand that smooth. The next steps will involve the faceplate and getting that ready with the base of the ball for this to go on, and I'll cover that in the next steps. Well, as you can see, I've finished sanded the bottom. This was just done on a 6x48 belt sander, and I just wanted to make it smooth. Certainly it's not going to accept a finish right now because we're going to put this onto the base of the bowl, and I've decided to put that onto this really beautiful piece of bird's eye maple. This piece of bird's eye maple was cut from a log, pardon me, actually from a board that was very rough. It's just very rough sawn, and that's how it was cured. Both surfaces are very rough, and you can see I've sanded this one down, but since this is going to go on the faceplate, I don't need to get it completely smooth. I just wanted it fairly flat just to accept the surface on the faceplate. I'm going to glue this directly onto the waste block that's on the faceplate, and here's one that I've used previously, and you can see some of the residue from the last bowl on there. This faceplate is a nice large cast iron faceplate, and the waste block is a piece of red oak, nice and thick, that I'm going to use to mount the bowl assembly onto. This gives me a nice bit of inertia too when it's spinning to really even out the pulsations from interrupted cuts that we're going to have later when we first start to turn the bowl. The next step is that I'm going to turn this surface flush and flat on the lathe. And then I'm going to put, like I have some of it remaining here, a pencil mark, which I'll also draw by laying the pencil on the tool rest on the lathe. The reason for that will come very clear later, and it's going to involve the use of this bearing that we'll be doing our assembly on. How this is employed, we'll show you later, and I'll explain why I do it that way. So let me go finish up the waste block and the faceplate, and we'll move on to the next steps. Okay, I've turned the surface flat, and I've drawn the circle on there, and all I did was this time I used a Sharpie just to make it show up a little brighter. Laid it on my tool rest and rotated by hand to get me a nice circle on the faceplate. Let's talk about this bearing table. You can see I made it out of just a hunk of particle board. This is from an old shelving unit. It doesn't matter what you make it from. And turned it on the lathe and mounted it to a Lazy Susan bearing. And I put a base on it to give it some height. You want to make this so that the neck on your faceplate here will go through the hole, and you want to make the hole big enough so that you have some range of motion on there. How this is used is you can eyeball it first and get it pretty close, and as you see, you rotate it, that circle should stay pretty much stationary. To help you judge, I just use a pointer in space here and move it slightly to adjust it until it seems to be running perfectly true. And for the purposes of this, I think that's pretty darn close. Maybe a little adjustment here. That's pretty true. Now you know that whatever you register on this faceplate to be rotating on center will be on center when you put this on your lathe, because since I drew the circle on the lathe and that's running true, anything registered to it now will be running true, such as what will be my base. So I can put that down, and this is not perfectly round, of course, but it's close enough to illustrate this. So now when I turn it, you can see if it's too far out of range. For instance, if you put it on this way, it'd be obvious that, yeah, we're off. So this will help you get it pretty darn close to on center and maximize the amount of wood that you'll have available for your piece. Now I'm simply going to glue this on there with some yellow glue. When I am ready to take the bowl off of this waste block, I'll just use a bandsaw, reverse turn it, and do the foot. The reason I don't simply sand this flat on the belt sander is that not only do I want it flat, but I want both surfaces to be perfectly parallel. If I don't do that, you can imagine that if this surface here was slightly out of parallel with the bottom, then when I mount my bowl blank on there, it's going to, as you go around, be like this. Now on this blank, that might not be as crucial as others that are more complex layups. However, as I'm intending, I'm going to put a thin top ring on this. The thinner the ring, the more that run out will be obvious, because it'll be thin on one side and thicker on the other. So that's why I don't want to simply take this to my belt sander and make it flat, because it will be flat, but it won't necessarily be parallel. But if I turn this flat on the lathe, I know it will be parallel. So that's why we take this step. Let me go ahead and glue that, and I'll come back to you when this is set and ready to turn for the next step. Well, we're back and ready for the next step, and what I've done since last time is, as you can see, the base is glued onto the faceplate, and I have turned it flat. what this does, of course, it makes it flat for the next step, which is to glue on the segmented portion of this bowl. But equally important is the fact that I know this surface now is completely parallel to everything else. So this surface will run true when it's on the lathe because I just turned it on the lathe. So let's put this on our little centering turntable here and give it a spin. It looks fairly good, but I just want to, again, use that same pencil mark to align a pointer to, and we'll just confirm that this thing is running true. It's a little bit off, actually, so we will adjust that, slight movement, and that's good. Now, as I glue on the rest of the bowl here, and this surface, as you recall, is flattened on the belt sander, I'm going to go ahead, as I've already done, and cut a piece of veneer, contrasting piece of veneer that will give a nice dividing line between the base of this bowl and the main body. This is a hunk of Bubinga veneer, and I simply cut it with on the outside using a pair of kitchen shears. They're fairly inexpensive and they're nice and heavy duty, and they cut the veneer very nicely. On the inside hole, I just used a box cutter and very carefully, after I drew the hole, went around until I broke it all through. When you do something like that, try to be careful you don't crack the veneer, split it, because then it'd be much harder to cover that up. You want it a continuous piece, so it's a nice continuous line no matter how you cut through it. I cut the center out. Principally, it gives the glue that's going to be between here and the veneer an additional place to go as I start to glue this together. Also, since the center hole of this is not going to be attached to anything, there's no point in it being a continuous ring. Now I'm going to put the glue on the base of the bowl, and this turntable kind of makes that easy too. As you can see, you just kind of float some on there, and I get a popsicle stick and just spread it out a bit. You can see a couple of voids there. I don't care because I know I'm going to make the foot of this bowl more narrow than this by quite a bit, so they're just there, and who cares. Now put the veneer on and press it down in a few spots to help hold it in place. If you glued veneer before with yellow glue, you know that as it soaks up the glue, it hydrates it effectively, and it will make it wrinkle up a little bit, but that will soon flatten out when you put the glue on the other side. This particular veneer has some ripple in it already, but once you glue it down, of course, it flattens out. So I'm going to spread this around too. Now you can see I'm pretty generous with this because, as I recall, related last time, I'm going to use that hydraulic bearing effect a little bit to help me as I glue this on. Here's the bowl piece, and again I can just eyeball it. Now you can see clearly I can move this around pretty easily. I'm centering it, somewhat assisted by that hole in the center of the veneer, but you can see I'm way off. So now I can pull it in a little bit. You try not to shift the faceplate on the table, so I always try and hold that down and move it with my fingers, holding the faceplate down, and my other fingers will move the piece that I'm gluing on. Again, still off. See, using the yellow glue gives you time to position it, and I'm pressing down a little bit each time too, so that I'm starting to make that connection. The glue joint is starting to take shape, and I'm getting closer. But to really help me zero in, I'm going to get my pointer again. I'm going to set it up a little higher, and just to give me a visual reference in space for positioning this blank. And now I know how much to push it in what direction. Again, this is not totally circular, so you're not going to get it perfect, but you want it fairly close. And for this particular blank, absolute perfection isn't necessary. Later I'm going to show you a different layout blank where perfection really comes into play, and that's when you really push hard to get this precisely located. I still want to shift a little bit this way. You get the picture though. Since this is not completely round, I'm not going to agonize over it too much more. Now all I'll do is just put a weight on it. You don't want to really clamp on this, even if your bench is like mine where you can clamp underneath. If you clamp on it, it's very unlikely you get the clamp perfectly square. As that clamp pressure comes on, it's going to make this shift as it straightens the clamp out. You might not even realize it. Another reason you don't want to use a clamp is I'm leaving it on the bearing, and that clamp will probably destroy the bearing. That's pretty much where I want it. Now I'll just let the glue set.